Before we jump into the dynamic array based approach for this, let's first understand why not follow the legacy approach. The main issue with this approach is when new data comes in or the existing input needs to be changed. For instance, let's say somebody tells us that the offtake revenue rate will be different even for December. We will have to manually change this in every year for the month of December. That slows down the pace at which you could ask what if questions, and it also introduces a higher risk of error. And one more issue is in terms of updating when actuals come. So let's say we get the actuals for June. These 6 values need to change, but it's not just these 6 values. Some of the formulas as well. This again takes time and creates source of risk for us. And one more last problem is that when we updated the data, we pretty much overwrote what was there earlier. So if someone were to ask us, okay, what was the forecast before we changed it? Well, it's lost. We'll see how dynamic array addresses all these issues and how do we build a model. One of the things that we've been told is that, a point I raised was, what if December prices were supposed to be 35 as well? All that I need to do is in this table, I'm going to add one more month. Month number 12 is 35. I'm done. If we go back to our forecast, you will see that for December, it is now automatically picking up 35 every December. When historical data come, what are we going to do? June data was not filled up fully. You will see that the forecast would have started from June. Once the data is fully filled up, automatically our forecast shifts to July onwards. And in the historical sheet, June is auto-populated. Whatever. So what I'm going to do is, if you want to know what was the number before June, let me just do one thing. In this table, I'll shrink the operating metrics table for period before June. So I'll keep it only till May. But I've shrunk the table and June is out of it. Our forecast starts from June, and in our summary sheet, June is estimate. So we said earlier, you're overwriting a data, so you cannot go back in the legacy approach. Here, that's also taken care. Hi, in this video, I'm going to be teaching you how to build a financial model entirely using dynamic array and Lambda by applying our BEST framework. For this purpose, I'm using a biomass case study, which was originally published by the Fast Standard organization way back in 2011 perhaps. The reason I picked up this case study is so that you have a problem for which you have solutions under 2 different frameworks, the FAST framework and the BEST framework, so that you could compare and contrast them. You can go through the case study in detail. In the interest of time, I'm quickly jumping into a mind map I've prepared so that you can easily understand what the case study is all about. So here is a quick mind map of the case study we have. What we're going to do is we're just going to model till the gross profit level for this biomass power plant. Gross profit is going to be revenue minus expense. In this case, the revenue is going to be coming from 2 sources. Offtake revenue, which will be paid by the power purchasers, and gate fees, which will be paid by the farmers when they come to dispose of their biomass waste. The offtake revenue is going to be computed as power generated multiplied by a fixed rate. Power generated, we're going to calculate it by taking into consideration the quantity of biomass we're going to process multiplied by how much electricity that's generated with that quantity of biomass. How do we get the biomass processed? The plant has a certain processing capacity per hour. We're going to multiply that with number of hours worked. The capacity per hour is given to us as 3 tons. Number of hours, right now we have told that the plant will operate all through the day, that's 24 hours. And since we're going to model it on a monthly basis, we have to find out how many days the plant actually operated. This we can get it by taking the month end date, which we'll set up in our model, minus the month start date. Conversion ratio is also given to us as 2.1 megawatt hour per ton. As far as the rate is concerned, the rate is fixed for most parts of the year, but we've been told that it varies by month. We've been told that certain months like January and February, it's going to be different. And this month number we can directly get by using a month function on the month and date that we would have set up. The rate is given to us in a form of table. Now coming to gate fees. Gate fees is going to be collected from the farmers when they come to dispose of their biomass waste. So it's going to be charged on a per unit basis, and we've been told every month the farmers will be disposing of around 2,300 tons of waste. The rate is fixed at 17.3 per ton. Now coming to the expenses, we have only one expense, which is the waste treatment cost, and this is going to be paid based on the quantity of inventory that's left. So whatever inventory is still left, somebody has to treat it and there has to be a payment. This rate is fixed as per the problem at 4.1 per ton. And the ending inventory, how do we get it? That's going to be taken as opening inventory plus whatever biomass that has been received. And this detail will come from the biomass receipt, which we would have already modeled for gate fees. So that's 2,300 tons per month. From there, we're going to reduce the quantity processed. So opening inventory plus quantity received minus the quantity processed is going to give us the ending inventory, multiplied by the rate will give us our waste treatment cost. So from revenue, when we reduce the waste treatment cost, we get the gross profit. You can pause the screen right now so that you understand the problem in depth. And once you've understood, click proceed. Before we jump into the dynamic array based approach for this, let's first understand why not follow the legacy approach and how is the best framework and dynamic arrays make life easier here. I have the solution built using the legacy framework. You have the solution from the fast standard as well. Here's a snapshot of it. You can download it from their website and see. The two solutions are almost similar. Only difference is I have kept the non-time series data in a separate section rather than in a separate column. So the layout is slightly different. If you look at the problem, there are over 9 key inputs. We've captured all those inputs here. Most of the inputs are constants except for the offtake revenue rate, which varies for January and February. We have typed it manually everywhere with just different numbers taken for January and February. It's marked as an input. All other inputs are captured here. In addition to the input that we saw, there are a few more inputs which is on project start and end dates so that we can make the revenues and cost a zero for periods prior to project start date and after the project end date. The formulas are here. The only complicated formula you may see here is where I have a formula called whether it's operational. This one checks whether the current period is on or after the project start date but before the project end date. That's the only check that we are doing here. Otherwise, the rest of the formulas are all simple addition, subtraction, multiplication, division. Nothing complicated. You can download the file and go through the solution in detail. I'm not going to be going through everything. This was done very fast. It's easy to understand. So it's simple, it's faster, so it ticks a lot of boxes. Why not follow this? The main issue with this approach is when new data comes in or the existing input needs to be changed. For instance, let's say somebody tells us that the offtake revenue rate will be different even for December. So not just January and February. We will have to manually change this in every year for the month of December. So this is a 5-year model. I have to change it in 5 places. If it's 20-year model, I have to change it in 20 places. That slows down the pace at which you could ask what if questions. And it also introduces a higher risk of error because manual updates could mean some error. You could type it in wrong cell or you could type a wrong number in one of those years. Other issue is we've taken a lot of numbers here as constant, like what is going to be the input quantity per month, how much of biomass is going to come in. This could vary. A few years down the line, this number could change. Right now, that's not factored in the model. A lot of these items, gate fees, waste treatment costs, these numbers can change over a period of time. That's not factored in. And there are also a few more issues in this file. For example, the project start date, if that goes from June to July, the file works absolutely fine. I changed the start date to July, so the flag is operational turned to 0 here for June. The revenues have gone to 0. This looks great, but we expect the end users only to type the beginning of the month date as project start date. Because in case if somebody were to type it as, let's say, rather than 1st of July, the project is going to start on 15th of June. Ideally, I should be taking only half the month of revenue for June, but that's not what's happening. We are having revenue for the entire month, I should say. That's one problem. And one more thing is certain implied assumptions. The problem does say that the plant is going to be operational all through the year. There are no weekends, no holidays, but that's not explicitly captured in this. The way we are capturing that is that the number of working days, we are taking it as all the days in the month. Current month ending date minus start date. So we are not factoring any weekends or holidays. but that's not explicitly stated anywhere. The risk is, let's say somewhere else someone says that for some of the months, in one of the months, plant is going to be shut down for maintenance for a few days. There is no way to factor in that variable here. All this will require us to manually modify the formulas later on, which is what we want to avoid. And one more final issue is in terms of updating when actuals come. So let's say after we build the forecast, we get the actuals for June. So here are some of the actual figures. What I will have to do is, the actuals that we've got is for biomass procurement. That's one data that I'm going to change. Power generated, how much quantity of power got generated, the closing inventory. These are three operational metrics. The offtake revenue, the gate fees, and the waste treatment cost. These 6 values need to change, but it's not just these 6 values. If what I am going to do is, so the quantity procured is not 2300, 2240. Let me manually change it. Closing balance was 1420, and offtake power generated is 4100. Offtake revenue here is 99220. Gate fees is 9005. And waste treatment charges that we paid is 6400. We've changed these numbers, but we are not done. The user needs to be very careful and change some of the formulas as well. So for example, the processed amount is not 2240 anymore. The processed amount, I will have to change the formula for it as closing balance minus quantity procured minus opening balance. It's 2320, so the number is slightly different. Rate per megawatt hour that we got this year or this particular month is not 25. 25 is an input. We'll have to now calculate it. I'm going to take it as revenue divided by quantity. And the same change, I'll have to do it for gate fees. I'll have to do it for waste management charges as well, right? All these things have to be changed. So you're not just changing the input, you're also changing the formula. This again takes time and creates source of risk for us. People can make mistakes in any of these stages. I might have forgotten to change one of those formulas when I was updating it for actuals. One thing I already forgot is I should be marking this column as actuals now. I forgot to do it, right? These are some of the risks that we have, and that's where moving to dynamic array based approach is going to make our life easy. And one more last problem is that when we updated the data, we pretty much overwrote what was there earlier. So if someone were to ask us, okay, what was the actual forecast before we changed it? Well, it's lost. You will have to open a previous version of the file to see it. We'll see how dynamic array addresses all these issues and how do we build a model with fully dynamic array and Lambda, of course, applying our best framework. Let's jump in there. As we begin with our solution, we are going to keep certain fundamental principles in mind, the best principles. Firstly, our approach needs to be thorough. In the earlier solution, we saw there were gaps. There was no provision to factor in holidays. And if the project was getting started in the middle of the month, the file was giving us wrong answers. These kind of gaps needs to be thoroughly addressed. The file needs to be stable as well during user interaction and the update process. In the earlier approach, we saw that when the historical data was getting updated, some of the formulas, until they were changed, were giving wrong answers. We want the file to be stable and we don't want it to give wrong answers when the users are in the process of updating the data. And we want all this to be done in an efficient way so that the file processes all these things pretty fast. And finally, all this technically robust solution that we're going to provide needs to be balanced with human centricity. We cannot make our file too complicated for end users purely because we want it to be easier for the machines. Let's see how we apply all these principles in this solution. If you look at this file, I have a home sheet. This home sheet is not specific to dynamic array approach. I would be keeping this even in legacy approach. Here we are capturing certain metadata of the file in terms of what's the project name, whether we're going to see the file in units or thousands, millions, billions, whether we want the file on a monthly, quarterly or annual basis. We have all these things. What is the financial ending month? These are metadata. In a way, I would call it as metadata of the model. This dictates how the model appears. Where we are bringing in some human centricity here is If you look at the financial year ending month, ideally we want that to be mentioned as a number. So if it's June, I want end users to type 6, but that might be a little difficult for end users to do. It might not be very intuitive. So we're saying you type the month. We would take or extract a number out of it by using our function here, right? So it's human centric, but at the same time we are using robust formulas to convert that into numbers. We are doing it for almost all the parameters here. We are converting the text inputs into numbers. How it's done, you can open the file and see it. For now, I'll just move on from here. Now, moving on to the core project assumptions, what we have done is we have split the assumptions into two parts, scalars and vectors. Scalars are basically constants. So project start date is a constant, project end date, what is our hourly capacity? We are assuming that the plant capacity is fixed, it's never going to change. Number of hours per day is 24. What's our off time? Keep in mind, this parameter was not there in the earlier approach. We just assumed, the formula assumed that it's working all the day. It was not explicitly captured. Here we are capturing these inputs. We are also capturing in terms of what is the conversion factor, in terms of how much megawatt hour of electricity we can generate for 1 ton of waste. What is our base electricity price other than those specific months? What is going to be the electricity price for offtake revenue? What's our opening inventory? These are all constants. We have kept it as it is. Some data points which the problem describes as constant, which we think could change in future, such as gate fees, monthly procurement quantity, etc. We are treating it as vectors, and that's kept in a separate sheet where we have tables. The reason for splitting it into two tables is, or two sheets, is because tables, if they have to automatically expand, the sheet needs to be unprotected. Whereas scalar data points, as an end user, you may want to protect those sheets and just keep these cells unlocked. Just to allow this flexibility, we are keeping scalars in a separate sheet and vectors in a separate sheet. So gate fees and waste treatment cost. What we have done is we have just set up a separate table. Right now it has only one row. Effective 1st June 2011, we have got captured that as an extra variable. What is the effective date? What is going to be our gate fees and what is the treatment cost? As far as electricity tariff is concerned, the base tariff is kept in a separate sheet, in the scalar sheet. In here, we are just keeping the table where we are going to tell for which month the revenue will be different or the rate will be different. So month number 1, that's January, and month number 2, that's February. For these two, the tariffs are different. And here is our base tariff. I have cross-linking that base tariff number here so that when we are updating, the end user can see what was the tariff. It's in a different sheet, but they can see it. Again, we are trying to balance. In fact, one more thing that I try to do to balance the data is I also like to let the end user change the base tariff directly from this sheet, for which I'm going to use a form control. I'll go to the developer tab, and in the form control, I'm going to pick up this button here. I'll drag this up down button. I'm going to configure this. When I click up, I want the rates to change. When I click down, I want the rates to go down. So I'll format control here. And in the format control dialog box, I'm going to say the current value of the button is 25. Minimum is going to be, let's say 0 at the most. And let's say maximum is going to be maybe 100. And the incremental change should be 1. And the linked cell, I'll link this cell to the scalar sheet. This 25 base price. Click OK. So now what we have done is, because of the form control, it's linked to the other sheet. People get a feeling that they are changing this base tariff in this sheet by clicking on this up and down buttons. But actually it's not changing it here. It's changing it in the scalar sheet. Right? So we are giving that flexibility to the end user. Again, trying to balance between good user experience and robust technical architecture. So we have set this up. Biomass procurement plan, again, it's starting from 1st June 2011. We're going to procure 2,300 units or tons per month. We have set that as a table. Holiday list, I'm also setting up the holiday list here. There are no holidays as of now, but in this table, to make sure that the data is not empty, I'm taking the holiday as 29th February 1900, because that is a bug in Excel. 29th February 1900 never existed as a date, and we have that in the holiday list. So this is how we have set up the input architecture. Now let's jump to the formulas. In the calculation section, what we are doing is we're keeping forecast in a separate sheet. Historicals will come from a separate sheet, and we'll be combining them together in a third sheet. That way, we can clearly separate the concerns here, and we don't have to think about changing formula in one of the columns. The initial setup looks very similar to what we had in the legacy approach. Just a few differences here. The number of months here is obtained using a dynamic array. I'm starting from the operation start date as the first month, whichever month it's starting, and the number of months I'm getting it through a sequence function, sequence of 1 row and 60 columns here it's going to be, because number of forecast here is 5 and model frequency is 12. So 5 times 12 is 60, and that's what I have here. Before we get into the formulas, I think it would be a good idea to familiarize with some of the names that we have used here. So in the scalars, every cell that I have typed here has a name. So 1st June 2011, the operation start date, that cell is called op start date. The project end date is called project end date. We have hourly capacity, number of working hours per day, we call it as operating hours per day. The weekly off type, which is a number, we are calling it as off type in number. Megawatt hour per ton is the conversion factor for biomass tons into electricity. Base price of the energy, that cell is called base price energy, and opening inventory. These are some of the names that we have given for the scalars. As far as the tables are concerned, the gate fees and water treatment cost, we are calling that as the other rates table. The monthly variation revenue, where we have kept it, that we are calling it as price table. Maybe I should call it as electricity price table, but for now let me keep it as it is. Biomass procurement plan, I'm calling it as BF inflow table, BM inflow table. Holiday list is called as holiday list. Other rates table, price table, BM inflow table, and holiday list. These are some of the names that we are using. We don't need to know the exact spelling, thanks to Excel's IntelliSense, that's going to help us out. So firstly, what we're going to do is we have to find out number of days in the operating period. So the month has 30 days. We saw earlier that if the project was starting in the middle of the month, we have a bit of a problem. We don't want to take the number of working days as 30 in that case. So that's where I have number of days in the operating period. The logic is complicated, but the best framework says when you have such complicated logic, wrap it in a Lambda, which is very well validated and tested. I have a Lambda that's very well validated and tested called as tfn.slice. So the start date here is the operation start date. I am typing the date here. As I type, the IntelliSense gives me the number here. The period end is going to be a project end date. So what I am trying to find out is between the operation start date and project end date, how many days were there between that falls within the current month. So 31st May 2011 was previous month plus 1 will give me the start date of this month and 30th June 2011. This is a customized Lambda. The Lambda is available in the file. So when you download the file, you will get to see the Lambda. You can open the Lambda in the Excel labs and you can see its logic as well. So I'm typing this. We've got the answer. Just so that we see difference here, what I'm going to do is I'll change the start date from 1st June to 15th June. So I'm making it as 15th June. Now let's go back to the forecast. So we can clearly see the number of days we've operated is only 16. If there are no holidays, then 16 days is what we're going to have. But we do have a holiday list. We have a function in Excel called as networkdays.intf, which can help us factor in holidays. But problem is network days does not work with a situation where you have no weekly off. Network days expects you to give at least one of the week to be off. Again, no problem. So we have a special Lambda created for that. But for that Lambda to be used, I'm first going to do a small calculation. I'm going to figure out proportion between number of days falling in the operating period divided by total number of days. This is going to help me understand whether we are in the pre-operational period or we are already started the operation, or did we start the operation in between the month. For example, if this data was 0, that means this month falls before the operation start date. If it is 1, which means this month we were operating for the full period. If it's somewhere between 0 to 1, that means we know that the operation started somewhere in between. That's where this column is going to be helpful to me. And to get number of working days, what I'm going to do is I have one more function for this called as net workday lambda. This is like the net workdays.intl lambda, except that this also takes the number of weekend type as 0, which means no weekly off. So my start date is going to be previous end date plus 1. End date is going to be current end date. The weekend type is off type in number, and the holiday list, we already have a table called holiday list. But there is, we need to customize this. The customization is that or add some conditional aspects, because obviously we didn't work for 30 days or operate for 30 days in this month, including the holiday, because we know that number is 16, given that there is no holiday. I'm going to apply a switch function here, where I'm going to switch. The condition is firstly look at C17. I haven't named that cell because these are just helper cells. I don't want to be naming all the helper cells. That'll be too much name. So if C17 is 0, that means we are operating for 0 days. If it is 1, then this is what we want. How many working days are there between beginning of this month till end of this month? If it's neither 0 nor 1, what do we want? We want number of working days. So the same TFN lambda function, net work days function lambda I'm going to use, but not from the previous month date. It's going to start from the operation start date. So it's going to start from the operation start date, and this is going to be our ending date, forecast period date. The rest is going to be same, off type in number and holiday list. So this way I can factor in. So if you look at it, we are being very thorough here. Why am I using lambda in this particular cases? The formula becomes difficult. It becomes a black box. If you look at our best framework, what we're saying is that complex logics, write it as a lambda. Lambda can be easily validated. You may not be able to read the formula and understand the formula logic, but it can easily be validated. And once you're validated, you know it works fine. Then people just need to know whether you've used the right lambda. That's what we have done here. So I've got the number of working days. One of the things I do is all the helper cells, just to make sure that it doesn't attract too much of my attention, I gray it out a bit so that I can focus on the main body, and the helper cells will just be there. When I need it, I'll access them. Now we're going to model revenue. To model offtake revenue, what I want is what is the quantity we can process, for which I need the capacity. I generally prefer to have the formula flowing from bottom to top. So the main output is going to be at the top, the revenue, and inventory and other helper calculations are at the bottom. So processing capacity, how do we get it? So the hourly capacity is 3 times number of working days that we have here, days worked, times operating hours per day. This is going to give me our processing capacity. In this case, I've changed the number. We have taken 15 June as a start date. So first month, it's only 1152. How much are we going to procure? So what we're going to do is, for procurement, I've just, by the way, if you're wondering what we have done here, I've just put some placeholder formula so that the array stays there even though the numbers are wrong. Now coming to procurement. So to get procurement, the procurement number we are anticipating could change in future, monthly procurement. That's why we kept it as a table. So what I'm going to do is I'm going to take it as XLOOKUP. Go for the forecast period. It's an array. I'm going to add the # sign for it and look for that in the BM inflow table, effective date column. Look for these dates and pull out whatever is our monthly inflow quantity, procurement per month. I'm going to make one small adjustment here, two adjustment in fact. Right now it's giving NA error because 30th June doesn't exist in the table. In that table, the effective date is 1st June 2011. So what we are going to be doing here is, if the data doesn't exist, what do we need to do? I'm going to put the match mode here, which is the 5th parameter. I'm going to put the match mode as minus 1. So in case if the data doesn't exist, this is will look for the next lower date. What if we had put the effective date as, let's say, 1st July? In that case, obviously we are not going to be procuring anything. If the first month of procurement is going to be in future, in this month I'll be procuring nothing. So in XLOOKUP, in the fourth parameter, which is the if not found parameter, I'm going to put it as 0. We have got this in place. Our processing capacity is 1152. So can we just assume that whatever was procured or whatever was our capacity was processed during the month? The answer is no, because right now that works very well because our procured quantity is much more than our capacity. So obviously we will be able to process to the full extent of your capacity. But what if our procurement comes down? What if our procurement was only 1300? Then obviously we cannot be processing, we won't be operating in full capacity, right? We'll be operating only to the extent of what is available as raw material. So to tackle this, what I have done is we are going to build a corkscrew model essentially, where in a legacy approach you would be using a min function here, minimum of capacity or available materials. Dynamic array, that's a little complicated. So I have a lambda for this specifically. So I have written a closing balance lambda. So where we're going to put the opening balance. So we already have opening inventory in the scalar sheet. So let me go and select it, comma, and coming back to the flow, I'm going to say the flow is normally, it's going to be the procurement. Whatever I'm procuring gets added to my inventory. My capacity, if I'm processing the full capacity, I'll reduce it. But we need to apply the min condition. So I'm going to put a lower limit here. The lower limit is 0. This is a custom lambda that gives me the closing balance. How do I get the opening balance? I'm going to use the same lambda for closing balance. In the same lambda, if you look at it, there are two more parameters. One is the upper limit, if there is an upper limit. In our case, there is no upper limit. You can have as much inventory as that may happen. But there is one more parameter which is, do you want the closing balance or opening balance? 0 is for closing balance, 1 is for opening balance. In this lambda, they are documented well in the file. You can open the lambda and see it. So I'm just going to put comma 1. So we've got the opening balance. So now the quantity processed is not going to be simply the capacity. I'm going to get it as equals closing balance minus quantity procured minus opening balance. I could have written a separate lambda for this. For now, I'm just keeping it simple because this is a simple arithmetic operation. So I didn't expect or let's see a need for a lambda here. So we've got the capacity processed. Now let's come to revenue model. So we are going to look at the offtake revenue. So the offtake quantity generated is going to be the biomass processed multiplied by the conversion factor. That cell I named it as megawatt hour per ton. This gives me the quantity of electricity generated. We need price. The price we know is going to be same for all the months except January and February. So to get that, what I'm going to do is I'm going to use a XLOOKUP function equals XLOOKUP. Here is the month number. And this should be looked in the price table month number. In the price table, I have month. Just in case, I mean, I prefer typing, but just in case if you don't remember what this part is, this is in the vector, we have the price table column, month number, that's what I'm selecting, comma, tariff. What if you cannot find it? Because other than January and February, for all other months, this is going to give an error, except for January and February. So what we're going to do is the fourth parameter, which is if not found, I'm going to select the base price. The base price is a cell that's called base price, but XLOOKUP expects this to be a fixed number. So it doesn't expect a variable there or a cell reference. So you will have to use a plus sign here. So I've got the base price and our offtake revenue is going to be quantity into price. Gate fees revenue, I need to get the price. So I'll do XLOOKUP forecast periods, which is the above cell. I'm going to do it for the entire array. Again, if you remember, that sheet was called as other rates table, that table where we have this gate fees data. So for this period, I'm going to look at the effective date and pull out the gate fees number. And again, our match mode is going to be 0 if the data is not found, but our match mode is going to be minus found. So if 30th June is not there, look for the closest earlier update, the one below that. So we've got the price. Quantity received is already there with us in the biomass inventory moment. This is the quantity received. So biomass revenue is going to be gate fees. Gate fee revenue is going to be quantity received multiplied by price. And our total revenue in this case is going to be offtake revenue plus gate fees revenue. We are done. Coming to operating cost, the price wise, I'll just copy this formula as it is, paste it here. I'll just make a small change. Instead of getting gate fees per ton, I need waste treatment cost per ton. So I forgot the column name, no problem. Once you type the table name and open the bracket, the column is going to come here. I now got the column name, close the bracket. This number is here, and ending inventory, we already have it in the biomass inventory moment. Select it. And finally, we have got the waste treatment cost, which should be ending inventory times the cost per unit. And I'll also link it to this, to my operating cost. Right now there is only one item in the operating cost. If we had multiple items, we would need this aggregation row. Gross profit is going to be revenue plus the operating cost. So we finished the calculation in around 15 minutes, but that's all thanks to the Lambda that we already had in place. Otherwise it could have taken more time. But you saw, the formulas were a little complicated, too many XLOOKUPs compared to the earlier approach where it was all just multiplication, division, and addition, subtraction. Why should we do this? Now let's go back to the problems that we faced earlier and see how this easily tackles them. Let's go to the vector sheet. One of the things that we've been told is that, a point I raised was, what if December prices were supposed to be 35 as well? All that I need to do is, in this table, I'm going to add one more month. Month number 12 is 35. I'm done. If we go back to our forecast, you will see that for December, it is now automatically picking up 35. Every December. We don't have to manually change this. That's one great advantage. We'll also do a few more changes here. So let's go back to one more item here. We are saying the biomass procurement can go from 2300 to 2100 from 1st Jan 2015. Let me change the data here. 1st Jan 2015. I'm just going to add one row. 2100 ton per month. That's the capacity. I added it. If we go to the forecast sheet, again, we'll see from 2015 onwards, the procurement quantity will change from 2300 to 2100. We can see here it's automatically changing. We just had to change one small line, add one line, file is automatically taken care. Same thing is going to happen with our gate fee as well. What we've been told is that from 1st October 2014, the gate fees will be increased to 18.5 per ton. So I'm going to add a row, 1st October 2014. This is going to be made into 18.5. Keep in mind, on 1st October 2014, nothing is happening to the waste treatment cost. Very theoretically speaking, if I have to focus purely on technical architecture, gate fees I would keep it in a separate table. Waste treatment cost would be in a separate table. But the problem is end users will find it difficult to go to too many tables and change it. We already have 3 to 4 tables here. What can we do here is one compromise is that we fit both these in a single table, even though their changes can happen in different dates. One thing that we'll have to do is bring in some redundant inputs. So on 1st October 2014, gate fees is not changing, but since you've added the row, we'll also have to mention what would be the waste treatment cost on that date. I'll put it again as 4.1 because there is no change in it. I'm going to do the same on 1st January 2015, because on 1st Jan 2015 what is happening is waste treatment cost is changing. So that is changing from 4.1 to 4.5, but gate fees is not changing. So I'll have to retain it at 18.5. There is a bit of redundant inputs here, but as I said, it saves our effort from having two separate tables, and also the number of redundant inputs here are far lower than if you were keeping these inputs directly in every cell of every column. That's just two extra redundant inputs, which is well balanced, I would say. Right? We change it and our focus are automatically updating. One more problem that we talked about earlier was when actuals come. When historical data come, what are we going to do? In this case, we've already set up a table for it. I had grouped it earlier. So we are going to have this table where people are going to be updating the inputs. So we have May 2011. Right now, the gate fees of take revenue and waste treatment costs are 0 because May 2011 was a pre-operational period. The reason we had May 2011 is so that we could also have the operating metrics like inventory. The opening inventory is 1500. When we have tables set up like these things, what may happen is people may add certain placeholder rows, either by design or by intentionally or unintentionally. So maybe we added a row for June 2011. The best framework expects us to add a validation row so that later on, whenever we pull the historical data, we know that the June 2011 number has actually not been published. It's just a placeholder row that needs to be done. So we're going to add a column to check the validity of it. Basically, the is valid column, validity column, is just going to check whether all the fields have been filled up. You can do it using a count a function. Instead, what I have is I have a pre-built Lambda with me, which is going to check whether the row is complete, and I'm just going to check whether this entire row is complete. So for May, I'm getting true. I'm not getting true for June and this blank row because obviously the row is not complete. I have two tables as far as historical data is concerned. One is for the financials, another one is for the operating metrics. Let me apply the same isValid function in the operating metrics table as well. IsValid check is row complete. Call the Lambda for the current row. It does that. One of the things that we also need to keep in consideration, again, it's all there in the best framework. What if one table is filled up and the other table is not filled up? We don't want the data to be taken for a month if both the tables have not been filled up. So we are going to have a multi-table validation column in the historical financials. I'm going to add one more column here to check is metrics complete. I'm going to check this table. Let me not have the question mark. What is going to be there in this table? In this table, what I'm going to do is I'm just going to do a simple X lookup. X lookup for this month in the metric sheet and pull out what is there in the isValid column. Because if the metric that particular month is complete, the isValid should be true. I'll close the bracket. We're going to have a problem. I'm saying NA error in May. May 2011 exists in both the places. Why would we get a NA error? The reason is, in here May 2011 is typed as 1/5/2011 or 1st May 2011, whereas in the historical metrics the user has typed 31st May 2011. Again, sticking to best framework and the best principles, we need to be thorough. We need to anticipate such common user mistakes that could happen. It's very common. You may type month with the first date or the last date. It's very, very common. We need to anticipate it. So how do we fix this? So in this XLOOKUP function, what I'm going to do is, rather than taking the start date of the month, I'm going to say now EO month, get the last date of this month. When I put EO month of the current month, comma 0, I'm asking to look up in the last, look up for the last date of the month, current month. And just to be safe, I'm also going to apply the EO month function on the lookup column of the month table. I'm going to put historical month, comma 0, because there again, right now they've typed the last date, but it's possible that in the operating metrics table, they've typed the first date. So I'm applying EO month in both the places, and I'm pulling out the isValid column. So we have things falling in place. Only one issue is that we don't want to be applying this EO month in every other formula. So what I prefer to do is I have an enriched input sheet. This is actually not an input sheet. This is a calculation sheet where we are enriching the data that's coming from input sheet, especially when the input is coming from multiple tables. So in this, I'm going to handle two issues. One is I am going to take care of leaving out incorrect data points equals filter the historical financials table, the month column of the historical financials table to be specific, for two conditions. What are the two conditions? The row should be valid. So in the same table, in the same historical financials, look at the is valid column. That should be true. And in the same table, is metric complete sheet should also be true. I have applied this. Right now only 1 month for which it's satisfied, so we are only getting that 1 month. The other reason I'm applying this is also to enrich the data, as I said. So what I'm going to do is just to not reapply the same EO month in every formula. I'll have a EO month column here. So EO month of whatever month that we already derived, comma 0. So that when I'm doing an XLOOKUP, I can XLOOKUP it on this particular cell. I'm going to get the gate fees. Gate fees is coming from the historical financials. So the month column will be same. So let me get that XLOOKUP for the historical months in our historical financials table, month column, and pull out the historical financials gate fees. I'll repeat this process for the offtake revenue as well as the waste treatment revenue. I'm just going to change I can copy paste. I'll just have to change the column name here. So the gate fees instead is going to be offtake revenue. And waste treatment cost, I'll call this as waste treatment cost. So as I said, one of the purpose for creating this enriched sheet is to kind of not apply the filter in every place or not apply the EO month in every place. Get it here. So the cleaned up version is there, and all the formulas could now pick up data from this table because it's already a cleaned up table. So we are literally doing a data wrangling of sort. And another thing we are also doing is using the same analytics parlance, we are flattening the table. Our input is coming from two different tables because these are two different types of input. One is a financial statement input, another one is operating metrics input. Keeping it in two tables makes it easy for end users to spot the particular cell. Otherwise, we'll have too many columns. But for calculations, I don't need to search two different tables. I'm going to flatten the table, bring all the parameters here. So that's another thing I'm going to do. So what I'm going to do is I'm going to XLOOKUP for. So we've got this information here. I'm not going to take you through this, but once the data is loaded here, all this information can be directly pulled in our historical financial sheet. So this is enriched input that we created. That's flowing into our historical financial sheet here, where we are automatically picking up the data. Now let's see what happens when, or what needs to be done when monthly update is going to happen. Let's go back to the vectors sheet. So here we are saying there's a monthly update. In the metrics, the biomass procured is, we're going to add it as 2240. I'm adding half the information here. Power generated is 4100 megawatts. You can see here I'm adding it, since all the data is not added. If I go back to the forecast sheet, it still starts at June and our historical financial still flows only for May. That's the stability that we are bringing in here. We are making the file stable, that when people are updating the file in between, it doesn't affect our final calculations. We already factored in stability by adding the isValid row so that these stray rows and other things don't affect our calculation. I'm now adding the last item here, because once I add this row is going to satisfy the validation criteria. So waste treatment cost is going to be minus 6,400. Typed it. Now this validation columns have turned true. I think there are a couple of things that we need to fix. I'll fix that here. One is that I'm going to get the last reported period. I'll get that in the home sheet. So it's going to be max of in the enriched input, whatever months we have here in the EO month column. So I'm going to get that. This is the last reported period. So it's June. If the last reported period is June, I want the forecast to start from July onwards. So the EO month function, earlier we said start from the first month of the operation. We're going to, because it's forecast, we want it from the month, 1 month after the last reported period. That cell we call it as LR period, and it needs to start 1 month. So in the sequence function, earlier we put 0 to start from the same month. I'll put comma 1. It needs to start from the next month. Yeah. So now that what would have happened is, let me go back here. In case if June data was not filled up fully, you will see that the forecast would have started from June. Once the data is fully filled up, automatically our forecast shifts to July onwards, and in the historical sheet, June is auto-populated. Whatever happened in June, we are going to get the data. We can repeat this when July happens, when August happens, it will keep repeating. And if we go to the output sheet, here is where we are stitching both historicals and forecast together for presentation sake. Not a very complicated thing. What we are doing is between the start and end date, we are asking the users to type it. There are 16 months, and again, how many months are there between May 2011 and August 2012? I have a custom lambda for it. Time function dot number of months. I'm pulling it here. This function is telling me how many periods and that many columns I'm going to have. And automatically, because June is now actuals, May 2011 and June 2011, I'm getting the actuals. For subsequent period, I'm getting the estimates. For actuals period, it's automatically picking up data from our actuals table, not the estimate one. Things are automatically rolling. And here is the thing, in case if you want to check what if June didn't exist, what was our forecast before June? In this file, there's an easier way to find it, but there's an even better way, which I'll do in a separate video. So what I'm going to do is, if you want to know what was the number before June, let me just do one thing. In this table, I'll shrink the operating metrics table for period before June. So I'll keep it only till May. So here, since it's only till May, I have shrunk the table. You can very clearly see that only May satisfies the criteria. In fact, we have a small problem which I need to fix. I don't want to see the NA error when this XLOOKUP happened, because there is no June, and when there is no June, it's throwing an error. I'll put a comma 0 in this case. So if the data is not found, we want 0. 0, false, both are same. I'll just get false so that it looks consistent. So what you can do is, now that I've shrunk the table and June is out of it, our forecast starts from June, and in our summary sheet, June is estimate. So we said earlier, you're overriding a data, so you cannot go back in the legacy approach. Here, that's also taken care. And again, when I want June, I'll just drag it back. Right? I'll just drag the column and we are done. So as you can see here, when you use dynamic array and when you build it with the best framework, it takes some extra effort. First, you have to create all the lambda. But once the lambda is in place, creating the file becomes much easier. And once you built the file, updating becomes even more easier. All that we had to do for update is let the end user just type in data entry operation. No need to update any formula anywhere. And our overall file is going to self-update itself. Thanks for staying with me till the end of this video. I hope you found this video useful. There is going to be more videos that are going to come up regularly on how to build models with dynamic array in this channel, especially applying the best framework. So do subscribe to the channel, and if you have not heard of best framework, if you don't know what best framework is, do check out the framework from the link in the description. Thank you very much.